Hello students, and welcome to part 2, where we will focus on our second and third skills of this lesson. Let's first start with our second skill, which is to convert scientific notation to standard notation. Now, if you look at our examples, you can see that I've purposely picked these examples because the only difference between our first and our second problem is the type of exponent that it has. This first one has a positive exponent, whereas our second example has a negative exponent. We know that positive exponents indicate that it is a large number, and that negative exponents indicate that it is a small number. So you will see that even though these look very similar, they are drastically different sizes. To convert scientific notation to standard, you first need to write down the decimal that you're given. Now, you take that decimal and you are going to change the place value 8 place values larger. So take that decimal and we're going to move it 8 place values larger. 1, 2, 3, 4, 5, 6, 7, 8. So our new decimal will be here at the end of the number, which makes sense because when we fill it in with zeros, this is a very large number. Now, you may not leave your final answer with these place value holders along the bottom. Instead, you need to rewrite the amount in standard notation. Now, we do not need to put the decimal at the end because it's understood that it's there without it because this is a whole number. So put your commas in every 3 places from the decimal and we get 511 million. Now, let's look at this second example. We are again going to take very similar steps. We are going to start with that decimal and we are going to be moving the decimal 8 place values as well, but this time we are going to move it 8 place values smaller. So we're going to take that decimal and move it to the left. 1, 2, 3, 4, 5, 6, 7, 8. So our new decimal will be here at the beginning of the number. So 1, 2, 3, 4, 5, 6, 7, and the 8th place value is the 5. So we need to fill in with 7 zeros, 3, 4, 5, 6, 7, and then 5, 1, 1. So this is the decimal that is equivalent to the scientific notation. Notice, both of these have the 5, 1, and 1 in them, but you can see that this one makes sense because it's a very large amount with a positive exponent, and this is a very small amount with a negative exponent. Alright, let's look at the next example. We have the number 7, so we're going to write down 7 times 10 to the power of 4. So we're going to change the decimal place 4 place values to make a large number. Well, where is the decimal point in the number 7? It's after. So we're going to take that decimal and we're going to move it 4 places to make a larger number. 1 place value, 2 place values, 3 place values, 4 place values. So our new decimal will be here. Fill in with zeros. So we get 70000 or 70,000. Alright, last example. We have 7 times 10 to the negative 4 power. So we are going to move the decimal 4 place values, but we're going to move it to make a smaller number. So we're going to take the decimal in the number 7 and move it 4 places to the left. 1, 2, 3, 4. So we get 0.0007. Alright, let's move on to the third skill and apply our knowledge. In June 2001, the Intel Corporation announced that they could produce a silicon transistor that could switch on and off 1.5 billion times a second. Express the speed of the transistor in scientific notation. A transistor is part of a computer. So, a transistor could switch on and off 1.5 billion times. So if you think about a billion that would be a 1 in the billions place, and then half of a billion would be a 5 in the 100 millions place. And then add zeros to hold the values. So if you think about this, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. So that's where you get the 1.5 billion. Now let's express this in scientific notation. We need a decimal, only one number to the left of the decimal, so our new decimal point is going to have to be here. So we write down only the non-zero numbers, so 1.5. We will always write times 10, and we'll have a power. The power is going to be the difference in place value between the old decimal, which was here, and the new decimal that we placed here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 place values different. So I'll write the number 9, and since this was a very big number, we'll leave the 9 as a positive amount. So it's 1.5 times 10 to the 9th power. Now, suppose you have $1 million in pennies. A penny is 1.55 millimeters thick. How tall would a stack of all your pennies be? Well, if you think about it, if one penny is 1.55 and you have 1 million of them, or you stacked that penny 1 million times, we could multiply by 1 million. So to write that in scientific notation, think about how many powers of 10 there are in 1 million. 1 million is 10 to what power? Well, this would be 10 to the first, second, third, fourth, fifth, sixth power. So we could have 10 to the 6th power. Now, if we wanted to express that in standard notation, we could take the 1.55 and move the decimal point 6 place values larger. So 1, 2, 3, 4, 5, 6. So we get 1,550,000 millimeters tall. That's very tall. All right, one more. NASA is planning a trip for a probe to 2 locations before heading home. The probe will leave Earth, okay, so here's Earth, and it's going to leave Earth and travel to the International Space Station, which is located 8.2 times 10 to the 5th feet from Earth. The probe will then travel to the moon, okay, so then it's going to leave there and go to the moon, which is 1.32 times 10 to the 9th power away from the International Space Center. When the probe lands on the moon, how many feet will it have traveled in all? In all means that you're going to add. So express that amount in scientific notation. So we need to take 8.2 times 10 to the 5th power and add 1.32 times 10 to the 9th power. Before we can add these, let's change them back to standard notation. So we'd have 8.2 and move the decimal 5 place values larger. So there's 1, 2, 3, 4, 5. So in other words, the International Space Station is 820,000 feet from the Earth. And we can add the distance from the Space Center to the Moon. Write down 1.32, and we're going to move the decimal 9 place values larger. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, 3, 2, and I counted as I put the zeros in, 7 of them. 1, 2, 3, 4, 5, 6, 7. Okay, now we need to add these together. So if we take and add them together, lining up the decimals because they are whole numbers, we get 1,320,820,000, which is still a very large amount. Now it asks us to express that in scientific notation. So right now it's in standard. We need to write a decimal with only one place to the left, one digit to the left. So we'll write down 1.32082 because we don't want to write any of the ending zeros times 10. Now we're going to have to figure out from here at the end to the new decimal point how many that would be. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So expressed in scientific notation, it would have to travel 1.32082 times 10 to the ninth power feet. Okay, so let's summarize what we've learned. Scientific notation is a way of writing very large and very small numbers using powers of 10. And scientific notation's exponent is crucial in deciding if a number is large or small. It will tell you which way to move in order to ensure that it does equal either a very large or a very small number.